Okay, how's the sound today? I hope it's clear today. Okay, then let's begin. So, in the previous class, we had learned about classes, how to write, programs using classes and objects. Okay, then let's begin. So, we have talked about how to write programs using classes and objects. So this was the first thing that we had learned in the previous class. After that, we had talked about class attributes, and we had also talked about class methods. Um, we had learned about constructors, what are constructors and how they work. We have also learned about static versus non-static members. And there was one more thing. No, that should be it. Yeah. So we had talked about these topics in the previous class. Let's just do a quick revision before we start with today's topics, okay? So let me clear that out. So the basic structure of a program from here on out would be class, my class. Then we have some class attributes, which are nothing but class variables. Then we are going to have a constructor which will initialize the class attributes, and then we have the class methods. So we could have multiple methods. So this was the basic structure of the class, and after the class attributes, after we have defined constructors to initialize the class attributes, and after we have written the class methods, we wrote the main function. Now inside the main function, we created objects of we created ob so this was a basic structure of a class, how to write a program using class and objects. Next we move on to the next topic that we talked about was static versus non-static. So if you recall, I had mentioned that static members they don't need an object. Just let me know when you are back online. Okay, so let's continue. So as I was talking about static versus non-static, so this was a topic that we had done in the previous class. If you remember correctly, static members of a class did not need an object so to be called. So they don't need an object, whereas on the other hand, non-static members were the ones that need an object to be accessed. So to access a non-static member, you would have to first create an object of the class and then use that object to access that non-static member, be it a variable or a class attribute or a class method, whatever it may be. Static, on the other hand, does not need any objects. There's one more thing, one more difference. Uh, this is not difference. You could not call it a difference, but the thing that how it actually works in the memory is that non-static members, whenever you create an object, let's say I have two objects like this. Okay, so these two objects I've created them inside the main function using the class. So inside memory, the non-static objects will each have their own copy. I mean, the objects will have each have their own copy of the non-static members, which means that every time I define an object, the non-static members are local to these objects that I have defined. So be it the variables or the methods, so every object will have a copy of its own. Whereas in case of static, what happens is there's just one copy in the class. So there's only one copy of a static member in a class. So it does not get assigned to every object. You just have a common member which is accessed by all the objects that you create. So one more difference between static and non-static is that um, members of the class that are defined as static are not copied for every object. There's just one copy in the class and that is accessed by all the objects. So let's say I give you an example. Let's say we have a class. We have a normal variable or a non-static variable A, and we have a static variable B. Now what happens is that when I create objects of this class, let's say I create two objects of this class. Now what happens is obj1 and obj2, which are the two objects in memory, they'll have each have a variable called A. So obj has its own copy of A, and the object second object has its own copy of A. But in case of the static variable, what happens is that there's just one copy of the static variable. So obj refers to this copy, as well as obj2 also refers to this copy. So there are not multiple copies. Like obj does not have its own specific b variable, or obj2 does not have its own specific b variable. There's just one copy. Both the objects access the same copy. So that is one more feature of defining members as static. So moving on, we also did constructors. As I told you, constructors are nothing but special functions. So constructors are special functions. Why are they special? Because they don't have a return type, not even void. And the second reason why they are special is because they have the same name as that of the class. So constructors are special functions in the sense that they do not have a return type like normal functions do, not even void, and they have the same name as that of the class. So these are the two features that makes constructors special. So moving on to today's topics, we have access modifiers. So in the previous class, I told you modifiers are of two types. So one was access modifiers, and the second type was non-access modifiers. So modifiers are basically of two types. Let's take a look at the first type. So what are access modifiers? These are keywords. These are basically keywords that are used to, specify whether I want my other parts of the program to access the part that has been declared with a modifier. So um, let's say I have this part declared as, let's say I have certain lines of code which has been declared as public, and what happens is that these lines of code are available to all the other parts. Let's say I have another part, this is another part, this is another part of my program. So this particular part is also available to this as well as available to this. ক্লাস নিচ্ছি আমি। Okay, so where were we? Yeah, so we were talking about the public access modifier. So the part of the program that's declared as public, that is the class. Let's say there are two things that we can declare as public. One is the class itself, or the the parts of a class. Let's say it could be attributes, methods, or constructors. One way of using the public access modifier is that we declare the whole class as public. The second way of using the modifier is that we declare the attributes, methods, or constructors inside a class as public. So there are two ways of using this access modifier. In the first case, the class is accessible by any other class. Let's say I define a class as public, then that class is accessible by any other class. Okay. Normally, we do not use any access modifier. We just write class and then my class. We do not use any access modifier here. So what happens is when we do not use an access modifier before a class, it by default takes up the default access modifier. What happens? So by default, if we do not specify any access modifier before a class, it is defined as default, and the class is only accessible by classes in the same package. So as I told you, this is used when you don't specify a modifier. So you don't specify a modifier, it is by default assigned a default access modifier. Now what happens? The class is only accessible by classes in the same package. Now, what do you mean by package? So what is this package that we are talking about? So to understand that, um, I guess you're familiar with the file structure, file directory structure in Windows. Like I have a root folder. First, I have a root folder. Under the root folder, I have subfolders. Let's say uh, I have a folder called package. Inside the package folder, I have several classes. So class 1, class 2, and so on. So this is the structure that, you know, or rather in Java, you would have something like this. So you'll have a root under which you'll have the Java folder, under which you'll have the package, and inside which you'll have the class. Just take a look at this statement. You have already used this statement in your programs. Let's say you are importing the scanner class. So you write import uh, java.util.scanner. So this is the line that you usually write when you import the scanner class. So what happens is that there's a root folder under which there is this Java folder. So this Java folder, this is the Java folder. Util is the name of the package inside which there is a class called scanner. Okay, so packages are basically a collection of classes, a collection of classes. So package is nothing but a collection of classes, several classes grouped together, just like we group together files in a folder. So just in the same way, several classes grouped together inside a folder is called a package. Here, util is an example of a package, and the scanner is the class that we are importing from util. Java is the parent folder of the package. So this is the parent folder of all default packages that are available in the Java programming language. In fact, when later on, when you will be designing your own packages, you'll have to put them under the Java folder so that you can use the import statement in this way. So all packages are inside the Java folder. So and each package has several classes inside them. So when we import classes, we follow this hierarchy. So we just follow this hierarchy, starting from here till here. The root folder is basically the folder inside which your Java is installed, right? So in Windows, you'll have C, then you'll have program files, under which you'll have a folder called Java. So by root, I mean this folder, or rather this whole path. So this is the root part. So you don't need to worry about this. Just remember, Java is the parent folder for all packages, be it default or whether the packages that you have written. So there will be a folder called Java under which there will be packages. So I'll have a folder here, then I'll have a package name, and then I'll have the class name that's inside the package. So you just need to remember that packages are a collection of classes. Okay. So what happens? Let's come back to the topic at hand. So what happens is that when we declare a class, so this portion here is for classes. This portion here is for class members. Okay. So in case of classes, when we define a class as public, the class is accessible by any other class, irrespective of the package. So irrespective of, so what does that mean? Let's say there's a package called util in Java. There's also a package called IO. Normally we write these two statements. So import java dot util dot star. So I'm not specifying a class name. It just imports all the classes inside the util package. Similarly, we write import java dot io dot star, which in turn imports all the classes in the IO package. So these are two packages. Util is a package, IO is also a package. What happens is that, let's say I have a class here. Let's say I have a class that is declared as public. So what happens is that, irrespective of the package in which this public class resides, may it be the util class or the IO class, I normally do not need to, import the util class and then access the package. So defining a class as public states that I can directly, use that class. Consider the system class, as in the system.out.println statement. So this system class is a public class in the sense that we do not need to write an import statement, any kind of import statement, to use this specific class and its functions. So system is basically a public class. If it had been the scanner class, then we had to write this statement to import the scanner class first, because scanner is not defined as public. So we have to import the scanner class first and then use it in our program. But in case of system, What happens is, since it is not a public class, since it is a public class, so we do not need any import functions to import the class and then use it. We can directly use it. So I hope this is clear. What happens when a class is defined as public? Now, what happens when a class is defined as default? If a class is defined as default, let's say a class is defined as default, what happens is, let's say I'm working with the util package. So a class inside defined as default inside the util package, I will not be able, let's not talk about util. Let's say a class is defined as default. What happens is that I'll not be able to access it from a different class. In the sense that, from a different package. Let's say presently I am working under Java. So project 1 is my current package, and I have a class here called my class 1. So I have this path, file path. So under the Java folder, I have my package called project 1, under which I have a class. Let's say under the same Java folder, I have another package called project 2, inside which I have a different class. Let's say my class 2 web class. This class is, let's say, it's defined as default. What happens is, inside this class, when I'm trying to access, let's say I'm trying to define objects using this class, it will give me an error since it is defined as default, and the packages are different. Let's say I'm writing another class inside the same package. Okay, let's say this particular class was being written inside this folder itself, this package itself, then this wouldn't have been a problem. The default access modifier would not have been a problem. Let's say I have a different folder. I've moved on to a different folder, a different package, and I'm writing a different class there. And I'm trying to access the class from the previous package. But the class is defined as default. So here I won't be able to access this class. That is what they are trying to say. So the class is only accessible by classes in the same package. So I have package 1 and I have package 2. So I have a public class, sorry, let me write it under this. So I have a public class here, and I have a default class here. Let's say I have another class here. I have one more class here. So this class can access this, but this class won't be able to access this particular class because this has been defined as default. On the other hand, this class can access this as well as this because they are in the same package. So any classes that are in the same package as the default class will be able to access the class. But let's say there is a class inside a different package, they won't be able to access classes defined as default. For that, you need to define this as public. So once you define this as public, this class again has access to this. particular class inside the second package. So I hope access specifiers are clear with respect to classes. Now what happens for class members? By class members, I mean attributes, methods, or constructors. These are the three types of class members that can be there inside a class. So what happens to them when we use access modifiers with them? So let's say I have the public modifier. So I've defined a class member as public. What happens is that the code is accessible for all the classes. So defining something as public means that it's accessible to everything and everybody. On the other hand, if I define something as private, the code is accessible within the declared class. So this gives me a little bit more control over the data inside my class. In case of default, what was happening is that classes in the same package could access the default classes, but in case of private, only the code inside the declared class will be able to access something that has been declared as private. So the code is only accessible within the declared class. Doesn't matter if I'm writing another class in the same package and trying to access the private the members that have been declared as private, I won't be able to do so. So let's talk about, so packages are over. Packages can't be declared as private. Packages have just two access modifiers, public and default. Now moving on to the class members, we have various other access modifiers apart from public and default. So a public class member is accessible to everything and everybody. Let's just remember it in this way. So public class member is accessible to everything and everybody. Uh, Whenever I define a class member as private, that changes the scenario. So a private member, let's say I have a class. Let's take an example. I have a class. Inside this class, I have a private member. Private INTA. Instead of public or default, I'm writing private INTA. So I'm specifying the variable or the member of the class as private. What happens is that, let's say this is the starting bracket of this class and this is the ending bracket of this class. So all the codes inside this particular opening and closing brackets, so all the code, all the rest of the code inside this class is able to access, you know, is able to access the private member. So I've defined a private member inside this class. Everything inside the class will be able to access this particular member. But other members which are written outside the class, they won't be able to access the private member of a class. Just like the name suggests, it's private to the specific class where it has been defined. Just like real world things. Let's say you have a private object. Let's say you have a private video game that you own. Nobody else can, access that video game. It's private to you. Whereas on the other hand, you go to a shop and rent a video game. So that is an example of a public public member. So that video game is accessible to everybody. Whoever goes to the shop to rent that video game can access that video game. So that's a public entity. Whereas a private thing that you yourself own and nobody else has access to it. Okay. So only you can access, your private members. So in similarly in case of a class, only the code inside the class where a private member has been defined can access the private member. Apart from that, outside the bracket of the class, any sort of code will not be able to access the private member. It's private to the class where it has been defined. So private members of a class are only accessible to the class where it's been defined. So the private members of a class are only accessible inside the class where it has been defined. Let's say inside the class. So private members of a class are only accessible inside the class where it's been defined. Again, we have the default access modifier here as well. What happens is if we define, let's say we do not have, normally previously when we used to write programs, we did not use any type of access modifier, be it with a class or with a class member. Those were by default, defined as a default. The default access modifier was used by default. What happens is, again, just like a class, the code is only accessible in the same package. That's all you need to remember. Default means whatever it may be, whether it is a class that has been defined as default or a class member that is default that has been defined as default, it's only accessible within the same package. When it has been defined as public, it will be accessible by everybody and everything. When it has been defined as private, it will only be accessible to the class where it has been defined as private. So class members, though, that have been defined as private will only be accessible to that class itself, or the code, the rest of the code that is inside that class. This particular thing is not necessary for you to know right now. So this part is not there in your syllabus. Since you do not have inheritance, when we will be learning about inheritance, we'll be talking about the protected access modifier. So you do not need to worry about that. Just remember this one, the public and default. In case of classes, there can be only two access modifiers, public and default. In case of class members, there can be three access modifiers as of now, public, private, and default. Okay, so that's everything about access modifiers. Now let's move on to non-access modifiers. So you can see this is one of the most important non-access modifiers that you will have to learn. And the second one is static. These are again out of syllabus. They are not in your current syllabus right now. So we do not need to worry about these. We'll only be worrying about final and static. Static, I have already told you. Static members are, whenever we define something as static, they belong to the class. So static members belong to class. Here, attributes and methods belong to class when defined as static rather than an object. So that is why I was telling you members which are defined as static are not copied for every object. There's just one copy inside the class. Since the static members belong to the class, so there is just one copy inside the class. All the objects share that particular copy. In case of non-static, every object has its own copy. Okay. What happens in case of final? So final is a new keyword. What happens when attributes are defined as final? Let's say I have something which I do not want to be overridden, overridden or modified. When will such a case arise? Let's say we have let's say we have mathematical constants such as pi. So the value of pi is always same. It's always 3.14. So in certain scenarios where we use constant values like mathematical constants, and we do not want our program anywhere, once this value has been defined, I do not want my program to change this value, this particular value, anywhere inside the program. What I'll do is I'll define my class, and let's say I want to define a variable that stores the value of pi. So I'll just define it as static final pi, and I'll assign it the value of 3.14. I'm declaring it static because since I just want one copy of this variable, not multiple copies every time an object is created. And I'm defining it as final because I do not want the rest of my code to change this particular value. So defining it as static ensures that only one copy of this variable along with its value is created when I create objects. And defining it as final ensures that this particular value does not change. This will never change throughout my program. It will always remain constant. So that's the idea behind, final. Let's say we want constant values which we do not want to change anywhere after declaration inside our program. We define it as final. Simple as that. Final in a sense, why is it called a non-access modifier? Because it does not modify whether I can access this value or not. It just finalizes the value that I'm storing in a variable. This becomes permanent. This value becomes permanent. So pi will always mean 3.14. I cannot do pi equal to pi plus 1. I cannot do this kind of operation or any other such operation which modifies the value of pi. This will give me an error. So when I want to fix the value of a variable, I'll define it as final. When I just want one copy of the variable, not multiple copies, when I'm creating objects, I'll define it as static. So I hope that's clear. So this is an example. So if you don't want the ability to override existing attribute values, declare attributes as final. Just as I told you, I do not want the value of x and pi to change. So I've defined them as final. So anywhere inside my program, I can access values. I can just access the values just like here. I'm just printing the value, so I'm just accessing the value. But when I try to modify the values, it will give me an error because they have been declared as final. Okay, so this is wrong. This is wrong. I cannot assign new values to the final objects that variables or attributes that have been defined as final. So that's about it for non-access modifiers. Let's move on to encapsulation. So in the previous class, we had studied about encapsulation. It was nothing. So encapsulation is nothing but a feature of object-oriented programming, which makes sure that sensitive data is hidden from the users. So this part is very important. Make sure sensitive data is hidden from users. So encapsulation means making sure that sensitive data is hidden from users. Okay, so normally we did not, implement encapsulation uh, in our previous programs that we used to write. So encapsulation can be more, prominently uh, implemented using the private keyword. Just a few minutes back, we had learned about the private keyword. So anything that is defined, any member that has been defined as private is only accessible to that particular class. So how will it, enable us to enforce encapsulation in our programming? Let's take a look. So let's take a look at an example. So let me write a program. Let's say I have a class. So I'm writing a class. Here I have Here I have a private member of the class. So I've defined the integer variable a as private. Now I leave some space behind and sorry, I leave some space and I write the so let's say I have the class, let's say I have the main function in a different class. Just for the sake of explanation, I'm using a different class. It will be clear once I'm done with it. So I have a class that has a private integer variable called a. I have another class inside which I have, let me write it down side by side so that it's easier to view. So I have another class which has the main method. So I'm not writing the whole thing. So here I have an object of the first class. So I've defined an object of my class. Now, if I do something like this, obj.a is equal to 10. This here will give me an error. Why? As I told you previously, since this variable has been defined as private, it can be accessed inside this class, but cannot be accessed inside another class, a separate class apart from this class. So I have this private member inside this class. If I write something here, they can access this value or this variable, but in a different class, Let's say I've created an object of this class and I'm trying to access this member of the class using the object, it will give me an error. Like if I'm trying to directly modify, okay, not access, calling it accessing would be wrong. I can access the value, but let's say I want to modify the value. Rather, I'm sorry, you won't be able to access also. Accessing will also be forbidden. So you cannot, neither you modify the value nor can you access the value from a different class. So this is an example of modification. Let's say I'm doing this sopln obj dot a. This is also going to give me an error. So in the first line, I'm trying to modify the value. In the second line, I'm trying to access the value. Both of them give me an error. If we directly try to access the member using an object. So for private, so now comes a problem which states that how are we going to access this, or let's say I want to modify, how will I do that? For that, we'll have, just like in this example, so we'll just have to write two methods. Let's say void get, which sets the value of a, and void display, which will display the value of a. Since we cannot directly access the value of this variable, so since the value of this variable cannot be accessed directly, so we have to find a workaround. So we define two methods, one to modify the value of the variable, another one to display the value of the variable. And instead of doing this, what we do is we call the methods to do our job. We call obj.get and we pass the variable, let's say the value 10. So 10 gets initialized to a, and we call the method obj.display to display the value. So that's all for today. We'll be continuing with, we'll just repeat this topic once more and we'll be continuing with the other topics.